All right, let's see if we can get through these application problems and do some more practice, and then we'll be done. So we have a tower. So here's my tower here. Okay, here's my tower. Okay, and it's a 24-foot tower, and it casts a 15-foot shadow. So here's the shadow. So it's a 15-foot shadow. What is the angle of elevation of the sun? Well, if you remember, the sun's up here, right? And the angle of elevation is what it makes with the ground because the person is looking up at the sun. So this is my missing piece. So if I'm looking at SOHCAHTOA, what I have is the opposite and the adjacent. That's an A, by the way. So that looks like I'm going to be using tangent. So the tangent of my missing angle, theta, is equal to the opposite over the adjacent. And to get rid of the tangent on this side, I take the inverse of the opposite side. 24 over 15. And so that should give me my angle measure. So the inverse tangent of 24 divided by 15 gives me an angle measurement. Let's do it as 57.99 degrees. Now we have a ladder that's leaning against the wall. Okay, so here we have a building. We'll just draw the side of that building with maybe a window or so we know it's a building. And we have a ladder that's leaning against that building. It's a 20-foot ladder, so that's that piece there. We're hoping that that's our right angle with the ground, right? Which, by the way, our building, our tower, we hoped was 90 degrees. The base of the ladder is 8 feet from the base of the building, so that's that piece there. Okay, what angle does the ladder make with the ground? So this is our missing angle here. So looking at this diagram, I'm seeing that 8 is adjacent and 20 is the hypotenuse. So the ratio that uses that is cosine. So the cosine of theta is going to equal the adjacent, which is 8, over the hypotenuse, which is 20. So to get the cosine to the other side, I do the inverse cosine of 8 over 20. So I put that in my calculator, and we get the inverse cosine of 8 over 20 as being a 66.42 degree angle. Okay. So now we're going to do some practice ones. And this practice stuff might involve finding the angle measure. It might involve finding the side. We just have to determine what's missing. If I see theta, I kind of know it involves finding the angle measure. So in order to find theta here, I'm going to do the inverse sine. So I'm going to take this off of this side and do the inverse sine of 0.42. So of 0.42 gets me, oops, too many enters, gets me 24.8 degrees. Again, this should be something that you do ahead of time. Come back and check and see if you got them right. Cosine of the angle is 1/2, so to get rid of it over here, I do the inverse cosine of 1/2. So I'm doing the inverse cosine of 1/2. I'm getting a 60 degree angle. Tangent, to get rid of it, I'm going to put it to the other side and do the inverse tangent. So the inverse tangent of 9.5 is 89.4 degrees. Sine, I'm going to do the inverse sine. Now this is going to be a little ugly to enter, but it shouldn't be an issue. You'll be seeing this a lot when we get to the unit circle. So the inverse sine of the square root of 3. I have to press the arrow once to the right to get out of the square root before I put division. And then I have the 2. Okay? And that also gets me 60 degrees. So this is just evaluating, and this one says to the nearest degree, so I should go back and fix these. This should be 25 degrees, this should be 89 degrees, and the other two are fine. This says to the nearest tenth. So this is just, can you type it in your calculator correctly and round it correctly? So the inverse cosine, 0.951, and then the inverse tangent. I'm just going to type them all at once. 6, 7, and then the inverse sine of 0.966, and the inverse cosine of 5/13. All right, so that first one was 951, so it's 18.0. Remember, put your degree symbol on there. The next one was 3.8. The 966 got me 75.0. And the last one got me 67.4 degrees. Down here, I have to find the angle measure, and I'm giving all the sides, so you really have your pick of which ratio you want to use. So if I set it up that the sine of A is the opposite over the hypotenuse, that would be 10/26. So that means I'm going to find A by doing the inverse sine of 10/26. I could have used cosine, I could have used tangent. I just would have used different numbers in it. 10/26. And that gets me 22, it says nearest degree, so 23 degrees. Okay, and to find angle B, I could say that the cosine of angle B is equal to, we'll check this one out. Cosine is adjacent over hypotenuse. That's 10/26. So the only difference here is the sine of the cosine when we switch that. So B is going to give me the inverse cosine of 10/26. So be very careful and take your time with it because it could get confusing because you start using the same numbers, but they are not the same answers. This is 67 degrees. And again, we could have done this that way. We did the one where we said, oh, if that's 23 degrees, then all three of those have to add up to 180. We could have found 67 that way as well. All right. And then these are the last ones we're going to be practicing. And each one of them has a diagram, so it should be easier. We don't have to draw it in. And they've labeled all the parts. We just got to figure out what we're missing and then what ratio to use. So we need to find the driveway's angle of incline. So this is the angle we're looking for down here. Angle of incline is the same as like angle of elevation. So it looks like 45 is my hypotenuse and 8 is my opposite. And like I said, I like to write it down every time. All right, so I need the opposite and the hypotenuse, so that looks like sine. So the sine of theta, the missing angle, is equal to 8/45. So that means theta is going to be the inverse sine of 8/45. Now this, I'm thinking, should be a very small angle because we're talking about a driveway on a hill. We don't want it to be too great of an angle, right? Let's make sure. So let's do the inverse sine of 8/45. And that is a pretty small angle. It doesn't tell me what to round to, so I'm going to give it a 10.2 degrees here. Now we have a plane, the height of the plane. Notice that these two things are not in the same units. We need to get them to the same units. And I told you before, you need to remember that 1 mile is the same as 5,280 feet. So the first thing I'm going to do is I'm going to change this 130 miles into feet. So 130 times 5,280. So that's going to get me, this number down here should actually be 686,400. So now that I have it all in the same units, I'm okay to keep going. So I need to find the angle of descent. So that's the angle of depression. Remember what we said we could do with that is opposite interior angle. If I find this one, it should be the same as that theta. So compared to this angle, 33,000 is opposite. And this number here that we found out is adjacent. So that should use tangent. So tangent of theta is equal to the opposite over the adjacent side. So in order to find the angle measure, I'm going to do the inverse tangent of 33,000 over 686,400. So I do the inverse tangent of 33,000 divided by 6,86400. And that gets me, and that's good because you don't want an airplane turning down at an angle too quickly or else it will crash. So it gets me a very small angle of 2.75 degrees. Okay, so now we have a tower casting a shadow. And what's the angle of the elevation of the sun? So that means this is the angle here we're looking for. So compared to that angle, we have the opposite and the adjacent. So again, that's going to be the tangent is equal to the 18 over the adjacent, which is 9.5. So to figure out the missing angle, I'm going to do the inverse tangent of 18 over 9.5. So inverse tangent, 18 divided by 9.5 would get me 62.2 degrees. And our last person, we have a person laying on top of this building, and it says there is a 38-degree angle of depression, so that's 38 degrees here. What that tells us is we can go to the opposite interior angle and call that 38 degrees also if we wanted to the head of the assistant, who is 170 centimeters tall. So that means this piece right here is actually 170 centimeters. Be careful because that 10 is in meters. We should take that to centimeters. So 1 meter is 100 centimeters. So that means this is actually 1,000 centimeters. We got to have everything in the same unit. Okay. If the assistant is 10 meters from the building, which we changed to 1,000 centimeters, how tall is the building? So remember I said it could still go back and look for the side. We're actually looking for this. And the height of the building is going to be x plus the 170. And we're going to keep that in centimeters. So it looks like the height of the building is the opposite side, and the distance away is the adjacent side. So that means the tangent, and this time we have the angle, of 38 degrees is equal to x over 1,000. So I'm going to do 1,000 times the tangent of 38 degrees to get my x. So 1,000 times the tangent of 38 degrees. So we're using sine, cosine, and tangent when we're looking for the lengths of the sides. We're using the inverse sine, inverse cosine, and inverse tangent when we're looking for the angle measures. So x is 781, so that's 781 plus the 170. So we're going to do 781 plus the 170 of the height of the man, and that gets us 951 centimeters. Okay, so that should be it. So right now what you need to do is go complete the closure if you haven't done so already, and submit that, and that's how you'll get graded for today. And if you end up with underlying questions, we'll take care of them on Wednesday when we meet. Okay, I will see you on Wednesday then.